Hey everybody, Mr. Quick here. We're going to be talking about Eureka Math / Engage New York Math, Module 1, Lesson 10 for 6th grade, the structure of ratio tables, additive and multiplicative. Multiplicative, that's a hard word to say. Okay, there's actually this lesson within the Engage New York framework is more of a whole group lesson where we're going to create something. So I'm not going to spend a lot of time on the video. This should be a fairly short video. I'm just going to show you a couple of different examples that kind of go along with the lesson. The actual lesson will involve you creating some tables in class, and we'll talk about that together, obviously, in class. But first, I want to give you a couple of examples here. We're looking at a chart that I've made, whoop, right there, and the chart is blueberries to strawberries. Now we'll say if you ever go to the store, sometimes you can buy, I do it every week because my daughter likes them, right? A blueberry strawberry mix. And let's say there's a 1-to-3 ratio of blueberries to strawberries in the container, right? So for every 1 blueberry, there are 3 strawberries. Now, if we were to continue down that path and say, well, if there were 2 blueberries, well, you know, if we make the 1-to-3 into a fraction, and then we wanted to make it 2, and then figure out what that new denominator would be, 1 to get to 2, you're going to have to multiply by 2. Same thing down here. Oops, spoiler alert. 3 times 2 give you 6. So we would have 6. We wanted to continue down the line. 1, 2, 3. Well, over here we would have 9. It's not the best 9, but it'll work. If we wanted to even continue to add on, we could go to 4, right? Over on this side, 12. Now, when you look at this table, point out a couple things. Every time you go down the blueberry column, you're adding 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. So you know no matter how far down the column you're going, you're adding 1 every time. We could go to 5, to 6, to 7, etc. When you go down the strawberry column, you're adding 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12, and we could keep going down. So that is those are, I should say, 2 relationships. That's how they're related. The blueberries, as you go down, you're adding 1. Strawberries, as you go down, you're adding 3. These, the blueberries and strawberries also have a relationship to one another, because 1 times 3 will give you 3. 2 times 3 gives you 6. 3 times 3 gives you 9. 4 times 3 gives you 12, etc., etc. So as we go down the list, if I told you there were 7 blueberries, you would know, well, I've got to multiply that by 3 to get the number of strawberries, which would be 21. Conversely, you would also know that to go the other direction from strawberries to blueberries, it's divided by 3. 3 divided by 3 gives you 1. 6, I know this doesn't make sense. It looks like I'm writing it the wrong way. In fact, I should not do that. 6 divided by 3 gives you 2. 9 divided by 3 gives you 3. 12 divided by 3 gives you 4. So if I gave you 28 strawberries and we wanted to find the ratio, blank to 28, blank blueberries to every 28 strawberries, we would know, okay, 28, I'd have to go 28 divided by 3. I picked a bad number there. Let's go 27 to make it easier. We don't want to have a fraction, right, or a decimal. 27 divided by 3, and I would know that equals 9. So I would know in that case there are 9 blueberries for every 28, or 27, excuse me, strawberries. Okay, so here's a quick example. This is a ratio table. So for every 3 hours someone works, we'll say Bill, why not, right? For every 3 hours Bill works, Bill is paid $24. As you go through this table, there's a mistake. And to help find that mistake, we're going to assume that the very first column is correct, You can't always assume that, but since this is kind of an introductory lesson, we'll start here. And let's say that that is correct. We want to find the ratio. What is the original ratio used to make this table? 3 to 24 is the ratio here, but what would it be if we wanted to say 1 to blank, right? Well, we can take that 3 to 24 and make it a fraction, 3/24. And then we want to find out what would it be if the numerator instead of 3 was 1. 1 to what? Well, to get from 3 to 1, I know I'm getting smaller, right? So I have to divide by magic number. 3 divided by what is 1? 3, right? 3 divided by 3 is 1. So if I do the same thing to the denominator, 24 divided by 3, I'm going to get 8. So the original ratio, or the value of the ratio, we could say, is 1 to 8, or 1/8. So I know that this times 8 gives me the pay. So Bill makes $8 per hour. For every 1 hour he works, he makes $8. Now we can go down the list and check. 5 times 8 equals 40. So that's correct. We know 3 times 8 is 24, so that is correct. 7 times 8 is, we've hit a roadblock here because they say 52, I say 56. So we know that this particular row is incorrect. Let's check here. 9 times 8, it is 72. So three of the four rows are correct, but we've got a big problem here. This is incorrect. And if we were to rewrite the table and make it correct, we can do that real quick actually. We can say hours and dollars. We know 3, 5, 7, and 9 are correct. We know 24 is correct. We know 40 is correct. 7 times 8 is 56. So that is now correct. And now we have corrected our table. We found the error and we corrected it. Let's try one more. All right, we've got another table here. We'll say for every blue ribbon, we have this number of yellow ribbons. Why? I don't know. We'll go with it. And this one kind of makes it easy for us right off the bat because we see the original ratio is 1 to 5. So it has a value of 1/5. That means the blue is 1/5 of the yellow, right? 1 is 1/5 of 5. Now, if we're going to go with that as our kind of our starting point, the 1 to 5 ratio, or 1/5 value, we know that 1 times 5 is going to get us 5. So hopefully we can go through quickly and see where we have errors, right? 4 times 5. Oh, that equals 20. So I'm going to mark this right now as a possible mistake, very likely a mistake. 7 times 5. Ooh, should be 35. They have 13. That's a mistake. And then 10 times 5. 10 times 5 should be 50. So we have another mistake here. So if I asked you to correct this table, could you do it? I think you could. Let's do it together. We're going to keep these numbers the same, these values of blue, 1, 4, 7, and 10. But we know it should be times 5. So 1 times 5 is 5. That was correct. That's how we got our original ratio and the value of that ratio. 4 times 5 would be 20. 7 times 5 would be 35. And 10 times 5 would be 50. So we could easily correct that mistake by doing that. Okay, that's all we're going to talk about today. We are going to do an activity where you're going to be creating your own tables. We'll be doing that in class. And I think we'll do really well with this. So let's check it out together. Thanks for watching.